Welcome back to the exam walkthrough. Today we're going to be doing 2025 Jan Unit 4, question number 3, question number 9, and question number 12. You can pause the video and solve the question. I'll show you the mark scheme and the examiner report at the end of the video. Okay, the first question tells us that two identical charged particles were placed in a vacuum 0.020 meters apart. The charge on each particle was 8 times 10 to the raised power of minus 6 coulombs. And then they asked us to give the magnitude of the force in newtons on each particle. We know the force, according to Coulomb's law, is equals to K Q1 Q2 over R square, where the value of K is 8.99 times 10 to the raised power of 9. So I'm going to plug that in, and remember, both the charges that we have, both the charged particles have the same charge. So we can put, instead of saying Q1 and Q2, we can just say Q times Q. So that's going to give us Q square over R square. Okay. So we just have to see where the charge is being squared and the distance is also being squared, and that's going to be B. Okay, question number 9 says the graph shows how the electric field strength varies with distance from a charged conducting sphere. Which of the following gives the electric potential at a distance of 0.5 from the sphere? Okay, so one thing that you have to remember is that the area from infinity to x distance under the electric field strength distance graph is going to be the electric potential. And the gradient of the electric potential against distance graph at distance x, so for example this is the graph, now at a specific point x, where this is the distance, this is the electric potential, when you find the gradient of the curve, that gradient, we're going to draw a tangent, we're going to get the gradient, and that gradient that we get is going to be the electric field strength at that point. Okay, so to answer this question, we need the electric potential from this graph, and that's just going to be the area underneath the graph from 0.5 to infinity. So it's going to be B. Not from 0 to 0.5, but from 0.5 to infinity. Okay, so A is not correct, and then C and D are obviously not correct because I've already told you that area underneath the graph is going to give us the electric potential value from infinity to that distance that we're looking for, which is 0.5 in this example. I hope that's clear. And then remember, the other relation is that the negative gradient, you can write it like this. E is equals to minus dV over dr. So the negative gradient of the electric potential against distance graph is going to give us the electric field strength value at a specific point, wherever you're looking at. So maybe 0.6 meters, 0.7, depends. The diagram shows a Van de Graaff generator. This is the device that produces a large potential difference by charging a conducting sphere. The conducting sphere of a Van de Graaff generator has a radius of 22.5 centimeter. The electric potential produced at the surface of the conducting sphere is 1.75 times 10 to the raised power of 4 volts. So that the charge on the sphere is about 4.4 times 10 to the raised power of minus 7 coulomb. So, pretty simple question. We just have to find the charge. We can just use the formula. The electric potential is equals to K times the charge divided by the distance from the center, which here would be the radius. So we just plug in the values and get the answer. We just have to find, we already know the value of electric potential, R, just need to find Q. So when you solve the equation to get the value of Q, you're going to get it as 4.38 times 10 to the power of minus 7 coulomb, which is approximately 4.4 times 10 to the power of minus 7 coulomb. Okay, next part. Next, part B says neon bulbs light when placed in a region of strong electric field. A neon bulb moves toward the charged sphere of the Van de Graaff generator. The neon bulb lights when the distance between the neon bulb and the center of the charged sphere is 32.5 centimeter, and they want you to find the electric field strength at this position of the neon bulb. So the electric field strength is equals to K times Q divided by the separation square. So here I have plugged in the value of K, the charge of the Van de Graaff sphere that's there, and then I've plugged in the distance between the neon bulb and the charge sphere that's there in the Van de Graaff generator. And now I'm just going to plug in the values in the calculator and get the answer. So you're going to get the answer as 3.73 times 10 to the raised power of 4 volt per meter.